So I'll start the presentation, Andrea, and then we'll get everything. So nice to meet you, all of you. This is Ruggero Poletto from the company CFD FEA Service. I work with Andrea to, let's say, Andrea works with me. That's the real point. In order to make the Mantium Challenge real. So let's say my company and myself is involved in what is happening under the hood when you submit a geometry for a Grand Prix, and Andre makes it possible to actually simulate a whole Grand Prix. We, as a cloudHPC, as a CFD sales service, as with service cloudHPC, we provide Andre and the Mantium Challenge with the IT infrastructure, with the hardware to perform the CFD simulations that are then used to evaluate the lap time for your automobiles. So a couple of words of CFD for service. We are an Italian-based company founded in 2018, and we started this service that we call cloudHPC in 2020. It's an HPC on demand. So it's basically a cluster where you can perform any type of CFD of engineering simulations with quite a wide range of software installed already in the platform. Mantium Flow and consequently OpenFOAM is one of the software that is installed in the platform, but it's not the only one. There are possibility to perform FEA analysis, possibility to perform impact analysis, thermal analysis, and so on and so forth. The whole platform is a sort of pay-per-use system. And in the past years, in the past months in particular, we worked very hand-to-hand with Andre in order to couple, to give the possibility, if you generate a simulation with Mantium Flow, to get the data, import them on cloudHPC, and run the analysis on cloudHPC. And then once the analysis is completed, download the results of the simulation. This is an overview of the software installed. Obviously, we have OpenFOAM, which is strongly coupled with Mantium Flow for the simulation part. We have FDS and CoSaturn, just to give a range of the CFD software. FEA analysis, we have implicit and explicit solvers such as Calculix and Codaster, or OpenRadios, which is quite popular for impact analysis. Every software has its own features, its own capabilities and limitations, and all the software that we are installed in the platform, generally, we are able also to provide support. So if you have troubles with any of your simulation with this software, you can write us a message and we can provide support and assistance in order to understand what the problem what was the problem with your software. And then many others. Other participant, just talking about SU2, another CFD software, Salome Mecha, which can be used to generate meshes, Energy Plus, Shilab, TensorFlow, if you're a Python maniac and want to implement your own Python script or artificial intelligence sort of thing, that TensorFlow or PyTorch, they're installed. We have ParaView and several other things. But obviously, the main topic today is going to be Mantium Flow and the Mantium Challenge. I think this is the second year we are working with Andre, and we provide the hardware. So what happens under the hood every time you submit a geometry is that Andre generates what I personally call the OpenFOAM dictionaries. So the setup of all your simulations. So every time, I don't know, there are 8 to 12 participants, it means that Andre generates about 10 different simulations that are going to be performed on cloudHPC. using the setup provided by Andre, the system generates the lift, the drag coefficients, and the heat transfer coefficients that are then sent over to another, let's say, simulation software in order to evaluate the lap time. So every circuit has a sort of target values for lift, drag, and heat transfer coefficients, and the closer you are to the target value, the fastest you'll be on the track. So yeah, Mantium Challenge is a teamwork. This is the Monaco Grand Prix that has been performed earlier this year. I think that for every Grand Prix, Andre, correct me, but there are at least 5 to 6 people involved to generate the results and to generate the video, to calculate the lap time. So it's like a community, a little community that all together, let's say, provide some sort of service or some sort of capabilities in order to complete the simulations.
It's actually correct. It's a bit sad that we lost our guy in Australia, but the data does travel the world. So it arrives with me in Germany. I send it to you to Italy to get calculated. Then there is also technical scrutineering. We have help from Denmark, the lap time simulation in the USA. So the data does quite the travel.
It's really also teamwork. I mean, and Andre is great because he's coordinating all these entities, okay, each of which does, I don't know, a little piece of the Grand Prix calculation. So congratulations to Andre and to his commitment into making the Grand Prix and this challenge real every month. So let's say for every simulation that is performed, actually the workflow is rather simple. Usually to elaborate this workflow, I use this representation. There are 2 blocks. On the left-hand side, it represents my local computer. On the right-hand side, it represents the cloudHPC, so internet-based hardware resources. So on my local computer, we have Mantium Flow installed. Obviously, I need to generate the geometry. I need to upload that in Mantium Flow. And using that, I need to elaborate an OpenFOAM case. This OpenFOAM case is transferred on the cloudHPC. Sorry, I just do this. So CAD file, we upload it on Mantium Flow. We elaborate the setup of the simulation. We can transfer it on the cloudHPC, where there is a combination between OpenFOAM and it's grayed out, but there is also Mantium Flow. They are used to simulate, so generate the mesh, simulate, and that's the OpenFOAM features. And then there is an installation, a customized installation of Mantium Flow that is there to generate the report. So all the images and all the Excel files, CSV files, and that file that are then used to extract the lift and drag coefficients for every car. This report is then downloaded on the local computer, can be downloaded on the local computer, and Andre then takes it and send it over to the USA to calculate the lap time or to do his activities. So the workflow starts with a CAD, Mantium Flow, still on your local computer. You transfer everything on the cloudHPC, you submit a simulation, and then you can download the report, I mean the results of your analysis. So these are the 2 blocks, local computer and remote hardware resources, and these arrows represent the data transfer. There are 2 main data transfer during the simulation. One is right after we set up the simulation. We upload the OpenFOAM configuration files on the cloudHPC, and the second one is once the simulation is completed, we download everything on our computer just to get the results in our computer to post-process them locally. All this data transfer, let's say, can be done in 2 or 3 ways. There is what I call the manual way. So using the website, you just upload the files or download the files. There is a procedure to do them via terminal. Another way through the API, and I think with Andre, we are working on that in order to embed these API calls directly in Mantium Flow so that the user will be able from Mantium Flow to submit the simulation. And in terms of hardware provided for every simulation, basically there are two different types of hardwares. There are AMD EPYC Milan processors at 3.3 gigahertz, and that's less what we call high core. And then there is the premium processor, which is the Intel Xeon Emerald Rapids at 4 gigahertz. It's about 50% to 100% faster. So this processor is like a generation beyond the first one. And this allows user really to speed up a lot the simulations. Already AMD EPYC Milan has been around since 2022, I think, so 3 years ago. It's not the most recent processor, but generally, compared to the processor you may have in your computer, it's generally faster, about 20% faster. It depends a little bit on your computer capabilities, but this is just to give you a ratio. So AMD Milan is a little bit faster than your computer, and Emerald Rapids is definitely like a premium processor. It's just come out in 2024 and will be soon replaced by EPYC Turing, which is the 2025 versions of the processors. Currently, the platform allows two different types of scalability. What I call horizontal scalability, which is the thing Andre uses the most, which is the possibility to submit several simulations at the same time. We used to have a limit of 40 simulations for each account. This limit after the summer has been completely bypassed. Now every account can submit even thousands of simulations simultaneously. And then there is the vertical scalability. Vertical scalability means assign more hardware sources to one single process to make it like simulate faster. Currently, every single simulation can be performed on up to 192 cores. That's the highest limit we have in the number of cores per single simulations. I can obviously submit 10 simulations, each of which has 192 cores at the same time. We have several instances, but for OpenFOAM, well, probably you get familiar once, and if you're going to use the cloudHPC, but for OpenFOAM, the high core is what generally we suggest. This is the AMD EPYC Milan I mentioned before. And then there is the premium, that is the hypercore, which is the Intel Emerald Rapids. So the premium processor, which is about 2 times faster compared to the AMD EPYC Milan. And then there are extra tools such as the cloudHPC storage, which I think Andre is going to show us. Connectivity is possible to connect via SSH to the simulations while the simulation is being performed. And the support, as I said before, all the software installed on cloudHPC, we are users also of those software, so you can ask us for some support. That's everything for my first part of the simulation. I leave the presentation to Andre for the tutorial and the possibilities of submitting a simulation on cloudHPC using Mantium Flow.
Yep, thank you. I'm trying to share my screen. Let me know if it shows up.
Yeah.
It's there? Okay. Just because I see some faces here that I cannot attribute to a MVRC team, let me just lose a few more words on what is MVRC. So it's a challenge. Some people started it, I don't know, many years ago on f1technical.net. So a bunch of engineers actually, but yeah, there are not only engineers involved, a lot of students. And what we are currently doing, if you go to the Mantium Challenge website, you will find technical regulations. And basically, what we do is we supply some kind of internal parts. In the last years, we've been doing Formula 1 cars. We have some regulations, how you can design parts onto the cars, and there are all kinds of volumes, but in a very simple way to say, you have to cover basically the internal parts and not have body element parts sticking out of these reference volumes. Very simplified. But what happens at every race, a bunch of teams, they submit their CAD geometries to me, and they've been doing CFD simulations on them. But now I get them and I do the reference simulation. I extract values such as lift, drag, lift balance, cooling performance, and that then later goes into a lap time simulator. And for those that are not familiar, so you could now download this CFD software, or actually the pre and post processor that Ruggiero was talking about, called Mantium Flow. Sorry, you download it here at Files. So here you can download files, you can download the CAD parts you would need for the challenge itself. However, there is also a webpage, mantiumflow.com, where you can just as well download Mantium Flow. Download button is maybe not that exciting, but what you do have is, I don't know my own homepage. So you have a bunch of tutorials as well. So Mantium Flow, it's kind of a misconception. It's not only to simulate cars, but cars have a lot of complex parts, fans, rotating parts, porous media, and so on. So if you can simulate a car, you can simulate anything. Anyways, let's get to the actual script. So this is the graphical interface of Mantium Flow. Now let's say I want to prepare a case. And one important thing to understand about Mantium Flow is it was developed to be the most simple to use CFD software. Everything you do is actually automated. There are possibilities to use your own settings, but in general, everything is automated. Let me just see, I prepared a folder for us. Can't find it. Where did I put it? Here. So I will just copy paste this case here. Oops, now I'm in it. Sorry, I made a mistake. It's already more or less prepared. And now, let's say we have kind of like the basic case of a Mantium Flow case. And how does it look like? At the minimum, you have a geometry folder, and in this geometry folder, you will have other folders that have, I hope, meaningful names. So you see vehicle body, and vehicle body contains now a bunch of STL files called monocoque, mirrors, helmet, and cockpit. In the folder wheels, you can find something like wheel RR, wheel RL. You might know it's, or you can assume it's rear left, rear right. In suspension, you happen to find suspension geometry. In porous media, you find something here called HXL, HXR. It's the heat exchanger, left and right side. And that's how you kind of set up a case in Mantium Flow when it comes to geometry. So now let's just open the case. Where is it? Oh, it's already this one here, webinar demo. Yes. So now you can see it has loaded the geometry. It colored it based on what type of a geometry it is. So nice enough. Wheels are dark. You can see normal geometry has different colors of blue. And now I happen to know that the lighter blue is a high resolution surface. And this blue here is just a normal resolution surface. This green is a special boundary condition. Here in a Formula One car, you have an air intake. Now, the main idea behind Mantium Flow is what you then do is you now tell him what do you want to simulate. So I have a bunch, if you just download Mantium Flow, you will already have a bunch of templates. And among them are these MVRC templates. I will just choose the normal MVRC template. And I could now click Build Case, and it will build the case so I can run the simulation locally on my computer. But if you don't like automated workflows, or you happen to know that the MVRC template, it just takes too long for you, you can also go into the settings. And let's say one major driver of simulation length will be, one second, will be determined by the mesh size. And one of the settings to change the mesh size would be the base cell size. So I'll just increase it. Another one is how many iterations will you run? So let's say we've run this car a few times. We know we don't need that many. So let's just decrease that as well. And as a Mantium Flow user, never forget to hit the Apply Settings button. And now we can go back here and we could build our case and run it locally. But we're here with the great sponsor of MVRC, our technical provider, cloudHPC. What we do is we say, prepare for cloudHPC. So I click that. It tells me it will prepare the case. We have to zip it up and then we can send it there. So we just hit prepare. And as Ruggiero mentioned, obviously I need to build a direct API, so we don't have to go this manual step that we will now do together now. But it also depends on user demand. So let's see what happened. We can see now it created these other folders. So there's a system, a constant, a 0, and a postprocessing.sh file. As a user, if you don't care about OpenFOAM, you don't have to worry about it. But if you are interested in OpenFOAM, here you can see, for example, the boundary conditions. This postprocessing.sh, it's a script. In this case, it's a script relevant to Ruggiero's system, cloudHPC. So these commands are made for his system. If you just run them locally, they will probably not work. You would have to click build case and you can run it locally. Anyway, the system did tell me I can now compress this. So I'll do a tar.gz. That took surprisingly long. So it's only 27 megabytes. So how can I now submit this simulation to cloudHPC? Well, I go to the cloudHPC system. I'm already logged in. And this here is my dashboard. And what you can already see here, I guess Ruggiero would later maybe tell us a bit more. But I can see here we have some simulations that I've conducted. So here you can see simulations from the Monza 2025 race. Over the weekend, to prepare for the webinar, I also simulated a case because I wondered what would happen with the simulation time if I increase the mesh size a bit, reduce the number of iterations. So how do I submit now my case? I go to storage. Wait a second. I upload that zipped file from a second ago. No. There we go. Or no.
Yeah, give it us. Just do it again.
Okay, there we go. Okay, 13 minutes, I don't believe it. Okay, so now we've uploaded the case. How do we submit it? Here you can see once more old simulations. So you see we create a lot of simulations. They usually all execute in parallel. So that really helps with conducting the race weekends. So all we now have to do to submit a simulation is we now select the CPU. How many we would run? I usually run 32, 48 because the MVRC simulations are simply not that large. They are maybe in the range of 8 million cells. So we do have to keep a balance of accuracy and approachability. Many contenders use their laptops. Let's just go 32. Then as Ruggiero just advised, we will use the HyperCore 2 gigabytes. This HyperCore is pretty new. You don't think that would be good for OpenFOAM?
Yeah, it's very good. It reduces the computational time by 50, let's say by 20 to 50%.
Okay. Any preference? Should we try it?
Hey, if you want to try the hypercore.
So now we just have to select our case. Where is it? Here it is. So you can see when you've uploaded a compressed case, it appears as the tar.gz. So that's the one we have to select. We do not select the mesh. We just directly go and tell him use OpenFOAM. In this case, 2412. That's what we use in MVRC. We save it, and I think that's it. Ruggero, maybe if you want, you could log on as me and show how we could monitor that the case is running.
Okay.
Obviously, it takes a few seconds. Let me see what else I wanted to tell you. Yeah. Yeah, maybe Ruggero wants to demonstrate a little bit how we can monitor the case, or we just go right to the next step, like in a quick show.
If you give me a second,
I think because it's still pending, there's not that much you can show right now.
It takes about 2-3 minutes for any simulation to actually start. There is not really a queuing system, but there is just an allocation time for the simulation. So I'll share my desktop, make sure. Okay, you should be able to see it. Well, now I'm basically following up the Mantium Chi account, so I can see all the precursor analysis that have been performed in the past months for the old Grand Prix, and this analysis that's running right now. It is still under pending, but you see, I don't now enter it's actually running. It takes still 1 more minute, so we'll be patient 1 more minute, and then we'll see what's happening. In here, there are some controls that can be used in order to interact with the simulation. For example, if you see that the analysis is going completely wrong, you can stop it. So there is a stop button that allows you to soft stop. It means complete the current time step and save the results. Or hard stop, it means completely cancel out the results as quickly as possible. You can synchronize because when you submit a simulation, the results are meant to appear in your storage, but they will appear only at the end of the simulation. If you are an intermediate step and you want to download the partial results, you have to click on synchronize button, basically. There's no other option. And then there is this view button that allows you to enter the details of your simulation. There are some fields that are displayed for every simulation, like the start date, the configuration of the simulation, virtual CPU, RAM. And then there is this output. This is a sort of log of what your simulation is doing. We still need probably 1 minute or something like that because the system is still in the preliminary phase of the simulation. The preliminary phase consists of the allocation of a dedicated hardware resources, in this case for the account Mantium Chi, and it will transfer into that dedicated hardware resources the OpenFOAM dictionaries. Once all these operations are completed, it will start the simulation with OpenFOAM. So now it's transferring the files, so it's just worth a while waiting a minute, let's say, for the simulation to complete, to actually start. What's peculiar is that once the simulation starts, we will also have remote desktop that allows us to open ParaView, to open log files, to actually interact with the solver like if it was on our local computer. So we have quite a good interchange of data and functionalities. Let's be patient. 1 more minute. Yeah, it has downloaded the files. It is unzipping them. And 1 more minute and the simulation is going to start. I wanted to reach the moment when we can actually see the remote desktop and I can actually navigate throughout the simulation menu and interact with that. Yeah, the content has been extracted. Now it's just a few seconds and the simulation will start. As you get familiar with the cloudHPC, also reading the output and understanding what it's doing is going to be quite easy. But obviously we have a guide available here under help, and in here you can get explanations about everything that's on cloudHPC. So yeah, remote desktop is now started. I just refreshed the page to make it appear more quickly. Yeah, so this is the remote desktop, and this is not my computer. It's just a computer in the cloud that's allocated for this simulation. In here in the desktop, I can actually see the cases of OpenFOAM that are going to be generated by the system. And I have a set of tools, of software that are available. So for example, I just double click on ParaView just to open ParaView and to actually see if I can open any mesh. So in here currently, obviously we are still working and there's no mesh, probably under the composer or something, but it's still like preliminary sort of things. So the mesh is still under generation. But you see, you can actually interact with ParaView. You can interact when the simulation currently is generating the mesh. Also, once the mesh is generating and is generating the results, you can interact with the results. Okay, so you can enter here and can, for example, you can open the logs. I think SnappyX mesh is the log file that we are generating in here. You can have a look at what Snappy is actually doing. So that's feasible at any time when the simulation is running. And obviously on the output, you get a feedback. In here it says Snappy is running with 32 processes, so 32 cores. And once Snappy will complete its mesh generation, it will start the CFD part. The process is also here is quite automatic, and even if we don't do anything, in the end we will get all the results saved in our storage page. So no need to come back and do some backups or something like that. So everything is performed by the system.
Yep. Maybe I can show how to download the results.
Yeah, I'll let you do it because I don't have results in my account.
Okay, so my screen is back. Anyone can see it?
Yeah, I can.
Okay, great. So after you submit a simulation, so for example, yesterday I did a test simulation. You can see here it says at 4:38 UTC. 1.5 hours later, it was done. I would like to download the results. And Mantium Flow can do more than just prepare a CFD case and help you run the CFD case. But what it does, let me show you. Let's wait a second more.
Yeah, the storage can slow down a little bit depending on the number of cases that are saved on the storage. Yeah.
Oh. So what Mantium Flow does is when it's done is it completely post-processes your case. So the entire post-processing is also automated, and you can imagine running a challenge like Mantium Challange. You want everything to be automated because I want to be fair to the competitors. I don't want to make a mistake and get incorrect results because I did whatever. So somewhere here I find, is it solution? Yes, I can find solution. No, post-process.
Post-process, yeah, that's the
correct
right one.
I download that one, and here's the download button. So I download it, and just like in a cooking show, I've already downloaded it. So it is here. And what you can find in here is this report. And what is the report? Vivaldi decided to take over and be the standard browser, so why not?
Yep, the report is, what's nice about Mantium Flow is that the report is a website, basically, with a full set of images, slices, streamlines taken from your cars from the Mantium Challange at least, and they are generated completely automatic. So with the simulation we are submitted in the end. Can you hear me? Oh, I think we lost Andrew. Well, so with the simulation that's been submitted online, you can get this website full of images, graphs, and everything. And everything is done with a few clicks of your mouse. So there's no really need to go into deep details. I just take time now to go through of the last 2 or 3 slides, and then when Andrew comes back, he'll take over his part. So the last bit is about the cost. Well, these are quite simple because given the fact that Mantium Flow is based on OpenFOAM, the costs relevant for these are just the core hours. So you want just machines that are allocate only physical cores, because OpenFOAM cannot take advantage of hyperthreading, for example. And so there are just 2 type of machines you can use. One is the high core and one is the hyper core. High core have a cost that range from 5 cents per core hour to 10 cents per core hour. Currently in the Mantium Challenge, we are able to perform the simulations using this spot unit price. So we can take this cost as a reference. And the hypercore, which is equipped with the ML Rapids, so a processor, a premium processors, quite faster compared to the high core, has a cost which is about twice more expensive, so 0.11 euro per core hour. When I say per core hour, I mean per physical core. Okay, so there's no need to allocate 2 virtual CPUs per to have 1 core. And then there are some discounts of opportunities for the Mantium Challenge. Some of them are our standard discounts. So for example, there is Andrea is joining the call. Andrea, you're back.
I'm back. Yeah, sorry
Yeah,
about that.
I'll proceed with a couple of slides and then we resume the download of the post processing. So given the costs that I said before, there are 2 or 3 types of discounts that can add on top of it. One is what we call the high use discount. So for basically it works like that. If for a specific month you use let's say a big number of hardware resources, you'll be provided a discount which increases proportionally with the resources you are allocating on a cloudHPC. So this discount can be 0% up to 20%, depending on how many hardware resources you are using on the cloudHPC. And this is applied automatically. No need to do any action. Any users will get the discount. And then there are some Mantium Challenge specific discounts. The reason why we're doing this video call is exactly this one. So one is, let's say, a benefit for the 2026, and that is proportional to the number of Grand Prix that a user has performed in 2025. The more a user is active, the idea is that we want to give a prize for taking part to the Mantium Challenge, and in particular to be continuously taking part to it, to keep the whole challenge alive. So for every Grand Prix you took part in 2025, you can get a 2% discount. So all in all, given that in 2025 there has been 5 Grand Prixes, you can get a 10% discount for Mantium Challenge participants. And this discount is on top of the high use discount. So all these discounts I'm going to mention, they are on top of one another. And then there is our another possibility, which is every time you register on the cloudHPC, you get some virtual CPU hours for free to test the platform and to perform a couple of simulations, probably in your cases. And this is 300 virtual CPU hours. Those are sufficient to perform, let's say, a couple of Mantium Challenge type of analysis. So that's another possibility, just to give it a go to the whole platform. And then what I said before, we are releasing a tool, we are releasing later this year, a tool that will couple CFD and artificial intelligence analysis, in particular machine learning. And for this, I would like to have a volunteer, Andre, I don't know if you have a name in mind later on, someone that can volunteer a little bit. There will be some data management, because we have to train the artificial intelligence in order to be suitable for a specific Grand Prix. But once we do that, the idea is to see how much this participant can be faster with this coupled CFD AI simulation compared to the same user without the artificial intelligence. So this is not really a promotion, it's just an experiment I would like to perform with any volunteer from the Mantium Challenge.
Yes, I knew there was some surprise coming. That's it. So yeah, we don't have too many MVRC teams here right now, but some might watch it on YouTube, but we can also definitely send out an email and use LinkedIn, of course.
Yeah. Now it's back to you, because you were about to show how to download the results and import them on the Mantium Flow.
Oh, just to briefly go back, so after you downloaded them, you can actually open them in your normal web, which just crashed my PC, which was very nice.
So qui stai guardando una cosa al computer, non riesco a levare l'audio dal microfono dal computer.
Okay, I deactivated the audio to Marco for the call. Yeah.
Thank you. Yeah, and when you download a CFD report, and like I said, it was generated completely automatically. That's a feature of Mantium Flow. So you can see all kinds of plots. In this case, a very interesting one is the overall pitch moment coefficient. That's on the MVRC cards what usually converges the slowest. So in this case, I said, hey, let's do 2,000 iterations, but maybe you want to speed up things, save a little bit of money, and you know your car. In this case, maybe 1,500 would be enough. That's what you get to know thanks to such kind of plots. Yeah, as you can see, the other ones kind of converged. Yeah, this is pretty often that the engine inlet isn't perfect, but you can see it fluctuates around some kind of a mean value, and Mantium Flow actually does not give you the end results of any plot. It automatically detects where it should average. So yeah, you can then see some numbers. So in this case, the exhaust surface, the forces on the parts. A nice feature is if you don't know what the part is, you can just hover over it and you will maybe get reminded what it was. So in this case, the things seem to be named nicely, front suspension, front wing. And then, yeah, an overview of the geometry you can always see. Also transparent. So in this case, there's not that much special stuff in the car except the radiators. So this transparent view helps. And then you can just see the normal stuff. So all kinds of slices, in this case, indicating the pressure range. We have the same for velocity. Now here you see the same with slices in Y direction. And then all kinds of 3D images as well. So here you see what you would find pretty often. Let me find a nice view. These kind of total pressure zero isosurfaces, which often help to detect areas of drag. you get automatically all kinds of streamlines. Yeah, and then also surface related post-processing. So in this case, near wall velocity streamlines. Here we see the total pressure on the car. What you want to see on a car generating downforce is a lot of red on the top surfaces, because that means you're pressing down. And let's see if we can find the lower surfaces. Yeah. So here we find, whoops, a little bit of the floor. Here you want to see blue, because that means you're sucking it down. So this car only has a little bit of blue around the diffuser, and here this leading edge and the front wing. Yeah, that was the report I wanted to show you. I forgot if I have any closing remarks. Let me just pull up my notes. No, that's basically it from my side. You've presented what we are doing to the MVRC competitors. I also support it, like in the whole challenge. Mantium Flow is free for everyone. And maybe also to explain, right now you can do Mantium Flow, or you will be able to do simulations on cloudHPC with Mantium Flow for the MVRC championship. We're working very hard to make it generally available, and I'm very, very hopeful to do it with the next release of OpenFOAM, which should be in December. So in December, then everything should be open for everyone. You can simulate whatever you want, including thermal simulations. So that's it from my side. Thank you very much for listening. Thank you very much for Ruggiero, great technical support and fantastic sponsor of the Mantium Challenge.
Yeah, as I said, I'm looking forward to next year, in particular for the coupled CFD AI simulation, to see if there is a real benefit out of it, because I think it can be definitely, I mean, a good test, also for everything we put in this particular tool the past months.
May I ask a question?
Yeah.
Okay. Who is your typical customer? Because at the end, there are 10 teams participating to the Formula One Championship, and most of them are already equipped with CFD specialists and CFD teams.
You are talking to Andre for the Mantium Flow, or to me for the cloudHPC?
Let's say both, as you wish. Because at the end is a similar question for
Andre?
I start, yeah. I mean, the Mantium Challenge as such, it's just a challenge open for everyone. It's more a hobby project. And the contenders, yeah, they come from everywhere. I know that some students run on their laptops. I know that there are engineers that have access to much more computing power. And now we're offering, basically everyone can now use cloudHPC. And in general, customers or users of my software, a lot of them out of motorsport, but also, how can I say, like strange niche applications. So yeah, with Mantium Flow, standard stuff like fans have been simulated, but what I would have never expected that Mantium Flow would ever simulate electric hand drills. But they have electronics in them. They need to get cooled. So in general, if you're doing something with an airflow, you can do it with Mantium Flow. And the great advantage is it's so easy to use. You don't have to be a CFD engineer. And as everything is automated, you have repeatable results. That's the idea behind it.
Okay, so you say Formula One is just an example.
Well, Formula One teams, they have other suppliers, but let's say other motorsports, GT races, smaller teams where you maybe have 5 people or something, they look into software like this.
Okay, thank you.
Yeah, instead, in terms of cloudHPC, the platform is used mainly by engineering firms, by some also companies in the manufacturing, pumps, HVAC, hydrodynamics, heat transfer. There are several software that are used quite widely. OpenFOAM is one of them. It's not the only one. And in general, it's seen as a tool that even if a company has the software in-house, even if they have hardware resource in-house, they can just rely on cloudHPC every time they need a further extension of the hardware resources they have in-house to speed up the simulations. In general, they can be optimizations design. They can be very big projects. For example, in civil engineering, the platform is quite used is for the fire simulations. And over there, sometimes they simulate a whole train station, a whole underground station. And so that for that particular big project, probably the hardware resources they have in-house, they're not sufficient. Or there are some companies that have like headquarters in 2 or 3 countries, and using a platform like this, they solve out the whole data transfer between the several departments, because users, they can log in into the account and check the simulation setup, the simulation performances from several locations. The whole platform is ISO 27001 certified for data safety. So you get like also this certification or proof of safety, let's say, in this regards. And the customers are as well from all over the world. We have about more than 3,000 users from North America, Europe, Africa, South America, Asia, Australia, everywhere.
Okay, thank you.
You're welcome. Yeah, what's difference probably, Andrea, and then we close, is compared to other software, we provide automation, which is the words everybody says, but also, I don't know, we provide support in these months, in the last 2 years that I've been in touch with Andrea. We exchanged tons of emails every time there was an issue with the simulations on cloudHPC for the Mantium Challenge. We got like some real-time support from him and vice versa. Okay, so that's another big advantage of let's say, of the team made out of Andrea and myself, let's say, of the 2 companies. From what I understood a lot, that's quite a big pro. Instead, like, there are simulations. So, I mean, I'm talking about cloud provider also, where you're left on your own. So you have like a bunch of functionalities which can be huge, but if you need the troubles, if you need support with that, then there is a fee to pay or something like that, or probably they are expert in IT and not expert in the CFD simulation, which is still a problem. So that's the peculiarity of this, let's say, this combination between Mantium Flow and cloudHPC together.
Okay.
I don't know if there are more questions from other participants. Otherwise, we can close the webinar. I recorded the webinar, so if everybody agrees, I can put it on YouTube for videos or for comments and stuff like that. And in any case, probably Andrea has, you can have all the contacts from Andrea for any questions also after the webinar. If you have any specific question to ask us, you can write Andrea or myself and get information and reply about your questions and curiosities.
Okay, thank you.
You're welcome.
Thank you. I would say
So,
everyone have a good night.
Yeah.
Good evening.
Bye.
Bye.
Bye-bye.
Ciao, ciao.